All right. So today topics, the content is first we're going to discuss about the continuous probability distribution and then the uniform distributions. How does it look like? And then the normal distributions, probably we covered in the following class. And then the standardizing a normal distribution. And then you will learn about determining that Z and X value when the area under the normal distribution curve. And then the normal distributions or normal approximations to the binomial distributions. So these are the contents of these topics. Okay, let's look at this continuous probability distributions. All right, a continuous random variable is random variable whose value are not countable, which means, as I said earlier, it is not a whole number. It is just a in the interval form, as I said earlier. So what is the difference? Those. Okay, it also can be assumed any value over an interval or intervals. Okay. For example, as you know, the life of batteries, height of person, time taken to complete a task, okay, and so on. Okay. Now, so this is usually how the frequency, continuous random variable look like. Okay. So it will be given in the form of range 60 to 61, 62, so on, 61 to 62. So there will be some interval between, some decimal numbers. So that's how we can determine those stuff. Okay. All right. So continuous random variable usually we can illustrate in the form of histograms with the polygons. All right. So always remember, I think some of students they're asking, how to draw that polygon and histograms. I already answered them, okay, every time. So always remember the polygon start with the lower boundary, away from the actual boundary. I mean the down one, lowest boundary, and then end up with that upper boundary. Okay, so this is the line is. Okay, all the connecting line, and then the histogram will be connected. Okay, all connected one to another's. Okay, there's a difference. Always remember. Okay, the probability that continuous random variable usually they express in the variable of x is, and it's assumed that single value is always a 0. So as exactly like in the discrete random variable is always like start from the 0. Okay, and total probability, okay, is equal to 1, as you said earlier. Okay, so when you just count everything, it has to be 1. So they mean for the continuous random variable, okay, and also called is the probability distributions curve. All right, usually we illustrate in the form of curve. Okay, not like discrete, it's different because it count based on the, since it's count based on interval, so you have to use the curve. And it is also called as the probability density function. Okay, so it also like fulfill the following condition, which is fx for all x, and then if you integrate the functions from minus infinity to the infinity, there has to be equal to 1. All right, so which means the area under the curve. Say if you find the normal curve, if you take the two hands, so from minus infinity to the infinity, so it will be has to be equal to 1. Okay. So for example, look at this curve. So which means the total, the area, the whole under the curve is equal to 1. So which means the total probability is. So in other words, it's we call as a 100%. Okay. So how are you going to determine? By using that integration concept. Okay. All right. So usually, in order to calculate the probability distribution, so if it is given the range in between A to B, so this is a boundary condition. So which is X is greater than A and X less than B. So it's bound between these boundary values, which is your lower boundary is A and your upper boundary is B. And that can be represented with the statements which is A less than X less than equal with X and X less than B and so on. So if it is one, if one point, if it is less, the other point has to be without equal. So it has to be less, and it's other way around. All right, you can write in this way as well. Okay, A less than X or less than B, or you can put it all them together. Okay, so this all can be written in this way. So there is three possible way where you can write your probability, continuous probability, continuous, they call as continuous random statement. So when you just illustrate in order to find that the probability for the certain point. Okay, say for example, they give you the lower boundary is A and the upper boundary is a B. So you need to calculate that the probability in that area under the curve. So that has to be, in between the probability 0 to 1. If you got answers more than 1 or less than 0, that means considers you need to check your calculation again, because it has to be between the given range, which is 0 to 1. Okay. All right. So the shaded regions, okay, again, same thing. So it is again exactly as in the curve. So you need to do that the same again. So which is for the case, you can write, all right, in the probability statements. So A and B, so you can transfer into these forms. Okay, just a way of writing. Okay, say they give you the shaded regions in this form 65 to 68, so which means the probability has to be written in the form of probability, okay, in bracket 65 less than equal X and less than equal than 68. So then you'll be able to find that the region which is we required to find. Okay. Okay, sometimes they give you just one-sided, all right? So that is, you need to calculate using a, because they in the equal doesn't show anything, so that is has to be equal to 0. Okay, if it is yeah, again same thing. So if it is given in the form as this or this, it still remain the same. All right, they require the same region. Okay, as how we did in a discrete random variable, the we, in order to calculate the mean value, so we do have for the continuous random variable as well the same way, but it's a different of formula. Okay, so the formula usually will be calculate mu, okay, equal to, this is a mean value, mu is a mean value which is equal to into X equal to, and give the integrations which is from -8 until 8. Remember, this has to be multiplied with the X. All right. So just now the formula is for the continuous random variable from -infinity to infinity fx. If in order to find the mean value, then you need to multiply with that X. So depend on the respective point which is the given. Okay. Variance is we have to in this way. All right. So we written as variance X. Okay, and the formula is E in the square bracket X minus mu all square, and then that is equal to integrate minus infinity to infinity in bracket X minus mu whole square and multiply with fx. So this is the variance for continuous random variable, or you can also write in this form is the same things. Okay, so this is pretty easy to show. So variance Ex square minus mu square, this is a mean value actually, and that is equal to an X square multiplied by fx, and don't forget to minus with the mean square. So this is the variance for continuous random variable. Okay. For the uniform distribution, okay, in a sample space that is contain a finite different sample. Finite different means is a continuity from that each every segments. It may occur the sample point where assign equal probabilities. Okay, all right. We discuss some of example that you know in better. For the continuous random variable, there is an infinite numbers value in the space sample, but in some cases, the value may appear to be equally likely. So some is the size is different. Okay, but we just we need to look into it. Okay, to identify whether it's a different size or the same size. Okay, continuous random variable also like appeared have the equally likely outcomes over the range of possible value process in a uniform probability distribution. So uniform probability distribution means that the class is step size would be the same. Okay, the step size, the class will be the same. All right, for example, look at these two example. How are we going to differentiate that? So if a short exits in a 5 meter stretch of the electrical wire, it may have an equal probability of being in any particular 1 centimeter segments along the line. Okay, so that is how we need to, we measure that the uniform figures. Second is in safety inspector plans to choose a time at random during that 4 afternoon in the 4 afternoon work hours to pay the surprise visit to the certain area of the plant. Then each 1 minute time interval in the 4 works hours period will be an equally likely chance of being selected for a visit. So means it's a uniform as well. So just keep that equally likely visit within the interval 1 minute. Okay, so this is some of the example to determine that the uniform size or uniform distributions. All right, so uniform distribution you can represent in the form of the graph. So which means if you just illustrate it in the graph, so you can show that from A to B, so that will be like straight line, okay, which is parallel to that your x-axis. If you just given in the form of the function, all right, so this is a piecewise defined function. So the functions given as 1 over b minus a, which is the interval between a and b, and a 0 elsewhere. Okay, so this is how you need to represent that the function and the graph for the uniform distribution.